right now I'd ask the panelists and presenters both to come up and sit at the front. Dominic and Khalid, and also Greg, Vasilios, and Ken. Yeah, so see, this is not our panel for this session. Thank you. Yeah. So let's just leave that slide up because that's our panel. Yeah, please come up and take a seat. I just want to comment a couple of things that Dominic said that really resonated with me. The feeling of going off a cliff with the installed base that you're running. One comment I would make is that I think definitely the genesis of the Open Process Automation Forum was a major oil producer thinking that they were running off a cliff with a large installed base of obsolete equipment that they couldn't maintain. And a chemical producer also, who I talk to very often, has a severe problem with this kind of integration. You're talking about hating gateways. Well, it's much more a part of people's life and in the operating space than it used to be, and not less of a pain. So what I'd like to do here is ask our panelists, excuse me, to introduce themselves and then explain what their role is and how they're related to these presentations, and give some reaction to the presentation. So if we start at this end with Greg, if you could introduce yourself.
So good morning, everybody. My name is Greg Bucco. I'm the Chief Marketing Officer for Universal Automation Authority. So Dominic made already a great job at presenting our association. So we are a non-profit association. We were established last November 2021. And our goal is to decouple hardware from software. So really helping what Dominic and Cargill wants to achieve, to decouple life cycles from the hardware and the software, enable the fact that you can increment over time, over the life cycle of your plant, your automation program, save costs by using ready-made libraries, and enabling digital transformation and link to, let's say, IT application. So we are a group of vendors, so technology vendors, of users, end users, system integrators, OEM, process OEM, universities and startup. And our goal is to maintain, increment, and further develop a runtime execution engine based on the IEC 64099 standard. The IEC 64099 standard is the standard enabling this decoupling of hardware and software. So together with companies such as Cargill, but as well Shell, Exxon, and others, we are looking to expand that community and to really have an ecosystem of products on which you can then build on and create your plan and truly decouple hardware and software.
Okay, thank you, Greg. And Vasilios Gerolas, Khalid mentioned you specifically, but I just ask if you would introduce yourself and your role in that program.
Thank you. So, hello everyone. I'm Vasilios Gerolas. I'm a manager of digital solutions in Schneider Electric. So my background is actually on mechanical engineering and data science, combination of these two, and actually this is where I did also my PhD many years ago. And after that in the industry, I have been in several positions, and always the common denominator in what I'm doing is how we can combine these two worlds, meaning the engineering with the data science, AI, in order to provide industrial solutions. When I say engineering, I mean first principle models, vibration analysis, durability, stress analysis, and then combine this with the AI, the machine learning models, supervised, unsupervised models, in order to build these synergies, from these two, and provide efficient solutions when it comes to optimizing processes, optimizing operations, improving the asset performance, and so forth. So this is exactly what I'm currently doing in my role in Schneider, where I'm responsible for this platform that Khalid also presented in his slides. And in this platform, we have three main pillars. It's the edge computing, the cloud computing, and the AI ML applications which run on top of this platform. And again, the goal is to optimize the operations and the asset performance in many different industries, including, of course, the oil and gas and the ESP application that was presented earlier. Thank you.
Okay, and our third panelist, Kangwon Chintamit, I hope I said it right.
Yep.
Please, would you introduce
All right.
yourself and explain what you're doing in VMware?
Sure. Okay, all right. Can you guys see me okay or hear me okay? Yeah, so thank you for having me here. Kangwon Chintamit. Actually, I work for VMware. Actually, just curious, how many of you guys know who VMware is? All right, okay. I will say it's a surprise because I went to some of the OT conference and then I see like 10 hands in the room, so this is not too bad. So VMware we have been around for 25 years, right? I mean, we just actually celebrate our 25 years yesterday. And the root of the company is actually on virtualization, right? So we came up with the premise that, we can decouple the infrastructure from the hardware, right? And that's what virtualization is. And it actually has been used a lot in the data center. And just in the last few years, as you heard from many of the panelists, right, the rise of the edge compute, we believe we have a lot that we can offer, right, in what we have experienced. And we can actually apply a lot of that learning to also at the edge. So my team specifically, I run solution architecture for edge compute. So we work a lot with, actually I think we have the privilege to actually work with both the IT and the OT side. So within the team, we have an architect that go and work with the customer, the application provider, and what we call the OEM, the hardware provider, on how to actually build and scale application and deploy the edge compute platform. So I'm happy to be here, and actually for the most part, I learned a lot in the last few days and hope to also offer some perspective.
Okay, thank you very much. I'm going to start with one question because Khalid kind of mentioned this, and in terms that you mentioned a fast loop and a slow loop, Khalid, kind of in your application space. And you also mentioned a partnership, kind of the partnership as it developed. I wonder, maybe both of you could explain a little bit how that emerged, because you had a set of applications that were kind of, you mentioned three different types, Khalid, but a fast loop and a slow loop and the machine learning. Can you talk about how that architecture developed between your expertise in the ESPs and Schneider? In other words, how did you get to that architecture as a team?
You want to start? You want me to? You good. Okay. I mean, from our side as the end user, the most important thing we have to do is make sure the requirements that we have are properly articulated to the developers, right? So we use product lifecycle management, generally speaking anyway, for our product development for hardware. So we use the same thing for doing the work we're doing with Schneider on the software side. So we always put engineering requirements together. And one of the engineering requirements, when we sat down and put it, was, okay, we need to do event detection, but we can't have event detection. The requirement is event detection needs to work immediately on site. So when we give a requirement like that, obviously when we give it to Vasilius and the team, their solution for it is, okay, you guys want this one, this has to go on the edge. So as we put the requirements together, Vasilius and the team will sit down and work out, okay, what makes sense to go on the edge and what makes sense to go in the cloud, depending on the business need that we have. That's typically how we went about it. You want to? Does that answer your?
Yes.
Help answer your question?
Can we see it from your side?
Yeah,
Vassilios?
actually,
Not-
Khaled described it very nicely. So based on the requirements that we got, it was clear that edge by itself or cloud by itself could not provide the solution. We wanted the hybrid model platform combining both the cloud and the edge. So for the hot analytics and the fast reaction to the event detection and so forth, all this is done on the edge. Now, at the same time, based on the insights that we extract on the edge, we want only the useful information to upload it to the cloud so that remotely anyone can just log into the system, I mean anyone from Alcourage, of course, can log into the system and see how this specific well is behaving, how in general the whole fleet of wells and the ESPs are behaving. So in order to solve the problems with lack of connectivity, or for example for the cost, because if you upload to the cloud everything, all the information, it will be extremely expensive. So we do all the work, the analytics on the edge, and upload on the cloud only what is really needed. That's how we came up with this architecture.
Okay, thank you. I posed this question probably to Greg and Dominic, but in this, you were talking about changing the software lifecycle, and how does, and the decoupling obviously makes that lifecycle much more flexible, the decoupling of I/O and hardware. But the question I kind of had is how can we, in the industrial space, accept having a much more rapid development cycle, like you were pointing on your slides, because usually our attitude is not to change things. So I'd kind of ask Greg and Dominic, how you contribute to that more rapid life cycle or a development cycle, and how we can adopt that with assurance. Because the attitude a lot of people have, and understandably, is let's not touch anything if it's still working. But if we try to make incremental improvement, we're going to end up deploying things. And how do we manage? We see the advantage, but how do we manage the risk of that? Can maybe talk about that software lifecycle a little bit?
I actually have a passion for that. There are parts of the application that you only want to change very seldom. Like, does a motor really work different in 20 years from now, right? Who knows? I don't think so. I think it will be the same. But other parts, you want to touch when you want to really add something that you want, right? It must be much quicker. Because in the past, when we were building a plant, you do it with a big project. It takes you a year to get a change in, right? To do it properly, safe and secure and legally. I did hear a nice presentation yesterday. Someone sending really smart people to a plant to do stuff quickly. And that's okay for a proof of concept, but not for an industrial plant, right? That's not doable. So to me, you can choose, you must be able to choose what you change versus change everything or test everything when you make a change. That's one. So because I have to quote again, Jaco, I think, I want to update when I replace a component. And I have a story about our current plant where we had an issue with one workstation, and we had to update the whole plant before we could work on that one thing. That is not practical, period. I mean, so some things change a lot, others change never, and by doing it in 499 or other things, you have to make sure you design your software in such a way that you can handle that, period.
Okay, Greg, I don't know if you want to comment on that, but the kind of more rapid development and deployment cycle in industrial applications.
Yeah, I see it from, let's say, from another side, and especially when we look now at the supply side, for example, and we see all the difficulties that we have to get hardware delivered. Mm-hmm. So this decoupling, I see it first more as a way to, let's say, overcome that. So change the hardware without having to change the software every time. Next thing is, at some point, it's mandatory to change the software. Because today, software lifecycle and hardware lifecycle are tightly coupled. So when you have a change of generation, you need to have a huge invest to go to the next generation. So at some point, you can say, okay, never touch a running system, runs 10, 15, 20 years, but you will have to invest at some point. Here, what we propose is to incrementally update your system, which doesn't mean that you have to update it every 5 months or every year. It's up to you to choose, but at least you have the choice and you get the flexibility to decide when you want to do it.
And if I can add one more thing, that kind of slogan I have within Cargill and also in industry, zero scheduled maintenance downtime. So for me, update is a scheduled maintenance. That's okay. So looking at OPAF again, right? I have 2 DCNs, and the computes are then also linked to that, but not under the DCN. I can move the container from one to the other, work on that thing and do stuff. I mean, so to me, it's all about architecture, right? I mean, but some things, and again, every 20, 30 years, you should redo your whole software, period, end of story, because it's a mess after 30 years. But only by choice, not because Windows tells you to, right? Something like that. That's I think that's the thing.
Okay, Kengwon, I wonder if you could talk a little bit about some of the applications and partnerships that you find on the edge that maybe are, similar or different to these applications, because I know you are, VMware is engaged in some of the test labs for OPA, but can you kind of give us a VMware perspective on the industrial edge and where you're engaged?
Sure. All right. Yeah, so I think we actually see a pretty broad spectrum, right? I think from where we sit, we get to talk to different type of suppliers and also the end users. And I mean, a lot of the projects start with focusing on the analytics, right? Because, I mean, you have sensors, maybe like we consider camera to be another type of sensors, right? Generate a lot of data. But a lot of them is still more around, hey, how do I make sense of the data? How do I actually make use of this data? But you don't yet have the control loop, because in some cases it's not really possible because the way that the application is sitting. But then we have some of the customers that are more forward-looking, right, and try to bring everything together, like be able to first collect the data, and then the second part, be able to feed that information back into the control loop. And that's why they kind of take a step back and say, okay, for us to do something like this, what should the platform look like, right? Instead of start throwing in like edge compute in different parts of the networks in order to do their short-term need. They take a look at, okay, in the longer term, if I need to go into like an OPA type architecture or have a full control loop, what is the edge infrastructure for them need to look like? And they have to take into account a lot of it on the networking part. Because you see that there will be a lot more communications and traffic that now has to go back and forth, like in the OPA case, between the DCN and the ACP. So that's something that you kind of have to keep in mind when you start looking at your edge compute project as a whole.
Okay, thank you. We have a few minutes left, and so I belatedly will ask for questions from the floor if someone would like to make a question or a comment. And I see one hand, two hands. Maybe we'll go to this one first, if that's okay. Oh, Ralph, oh, well, go up to the front if that's okay. And just identify yourself and ask your question, please.
Hello, I'm Brian Ashcraft with Dow Chemical. My first comment is engineers are very creative people. When you start turning them loose on some of these, the ability to add things to your edge devices, has the experience gone long enough to experience when folks are taking advantage of undocumented features on the hardware, and then you try to upgrade the hardware and everything breaks? from the software perspective. I know there's the standards for how things are supposed to behave, but there's a difference in how people program once they experience a behavior and they take advantage of it.
Okay, who would like to?
From
who would
either
like-
from either a consumer side or a vendor
Yeah.
side, have you experienced any of these trauma, version trauma problems yet?
Okay, Dominic, go ahead.
We do have that experience in some of our function blocks with PLCs, right? I mean, it's very classic for me. We use undocumented features, and then when they change versions, we have to change our code. On the edge, we don't do it long enough to do it. But my expectation is about if you use a standard, if you allow an engineer, if they have the capability and time, right? That's the other thing. You must give them time and capabilities as well, and that's also a problem nowadays. If you give them the freedom to do whatever they want in Linux, whatever, right? Make something nice, then the chance that that will break is more than if I base it on 499 using a vendor supply tool, right? I mean, either 4Diac from or the EcoRT thing from Schneider. I mean, so but we don't have the experience on Edge yet, but I'm waiting for it because hey, this is what you're saying will happen, right? That's no big deal for me. Either in one of the smart devices, because they are trying to sell us also smart valves, right? With all stuff integrated with software. Everything software will be buggy, right? So it doesn't matter. So it will happen, but and I don't think there's a solution for it, right? I mean, you're asking a question that you know people can't answer. It's okay, ask them as well. But yeah, I think it's difficult. Although maybe you disagree, but that's my opinion.
Any comment, Vasilios?
No, I don't disagree. Actually, I agree that if you leave an engineer, maybe he will break it, and I'm an engineer, and I will break it. And that's why it's very important to work in multidisciplinary teams, with the experts in each domain in order to come up with the optimum solution.
From a user perspective, it's an interesting point. Recently, we had a new motor controller that we had to develop with Schneider, actually. And their engineers copied the software from the previous version, which is like you said, engineers like to be, like to think outside the box. I think this was an easy shortcut. But what ended up happening is obviously some of the mapping wasn't correct and it just didn't work. But the check and balance we have on our side is we don't put anything in the field until it's been fully tested inside the facility. So we have a very strict validation verification process that will test everything before we put it out in 200-300 different pieces of hardware we have in the field. Otherwise, what you just described would actually end up being a pretty big catastrophe. So yeah, we're very careful to make sure that before we put something in the field, we validated it works properly, and it usually we pick. That's when we normally find the bugs and the problems before we send it out there.
Khalid, just to clarify, we found the solution right away, right?
I knew he was going to say that. Yes, you did.
Okay, there was a question in the back from Don Bertuziak. I don't know if he's still questioning, probably.
Yeah, Khalid and Dominic, thank you for substantive talks this morning. My question really is to Khalid. It's about the application. So are you doing the learning on well-specific basis, or can you do the learning fleet-wide?
Both. So we have to do the learning well by well initially, because every well is a little bit unique. But those learnings from the wells, as we bring them up to the cloud, then we send them back out to the fleet. So the fleet then learns from the individual wells. Now, it may not be exactly the same, but it allows you the sort of default starting point. And then if you need to tweak it for a particular well, it's much easier to tweak the learning from some previous learning that you had from another well. Does that answer your question?
Okay, any other questions?
To add something
go ahead,
on that, actually.
Vasilios. Sorry.
The problem is
didn't
that
mean to interrupt.
for some wells, actually, there is more data also than other wells. And that's why sometimes we have to group them and learn the model for the fleet, based on the fleet of wells. And then for each well, we can use techniques like transfer learning, in order to calibrate the model based on each well, if there is not enough data.
Okay, any other questions? Okay, seeing none, I just have to make two really quick comments. First, thank you very much for these presentations. I thought they were both excellent, and what I'm going to take away from them is a great appreciation for the difficulty of what artificial lift is, and the difficulties you get there. And from Dominic, I think one thing you said you could probably sell to the OPC Foundation, you said, using OPC UA without a companion spec, you're creating legacy. And I love that. I love that quote. I think they might too. But we had, I think, some really excellent presentations here, and so I'd like you to give your thanks to our presenters and panel. Thank you.